This video is going to go through section 9.5, and section 9.5 was how we add and subtract rational expressions. So before we get into actually adding them and subtracting them, I think one of the more important things to review is how do you find the least common denominator? Because you learned back in late elementary school you can't add a fraction or subtract two fractions unless they have the same denominator. They have to have a common denominator. And we are pretty good at coming up with the least common denominator when you're only talking about numbers. It's when you start putting in algebraic expressions, when you have these x's you have to work with to try to determine the least common denominator. It's an important skill that helps in this section. It's also an important skill that helps with the last section in this chapter. When you are looking for the least common denominator, what you want to look at is make sure that every denominator has been factored if possible. So for this first pair, 2x plus 1 is fine, but 4x squared minus 1 should be 2x plus 1, 2x minus 1. To find the least common denominator, you want to look at every unique factor. And unique factor, they have to be the exact same thing in parentheses in order for them to be the same factor. A lot of times students look at x plus 2 and x plus 4 and think that those are the same factor. They are not. Those are unique. Every unique factor has to be part of the LCD. So when I look at this, my least common denominator here, I have a 2x plus 1 and I have a 2x plus 2. So my least common denominator is actually the denominator of the second fraction. For this one, these have no factoring in them, but they are unique. X plus 4 and 4 are two totally different factors. If it helps, put the x plus 4 in parentheses so you can see that is a factor of itself. So that means my least common denominator would be both of them, the x and then times the x plus 4. For this one, we would need to factor this. You get x plus 1, x minus 1. Now looking, I actually have three unique factors, so all of them need to be part of the least common denominator. We have an x here, we have an x plus 1, and we have an x minus 1. The only thing that didn't get mentioned here, and I'll put like a basic example just to kind of show you, if you have something like this, x is the same factor. So you have a factor of x here, you have a factor of x here, a factor of x here. What you will use then is the highest power of that factor that shows up. So we have x squared as the highest power. So the LCD between these three fractions would be an x squared. And then you're going to look at your numbers. The least common denominator with a 5 and a 10 would be 10. So your least common denominator would be a 10x squared. So if you have a factor that repeats, what you want to do is use the highest power of that factor in any of the fractions that you have that you're looking at. So now let's actually get to the adding and subtracting. And I did not do any of the most basic ones, which were the ones that already had a common denominator, because those you should be comfortable with all along. I want to look at the ones that don't, talk about how do we adjust them to get them to have the common denominator, and then how do we finish them off. So first thing I need to do is factor. So this denominator factors x plus 6, x minus 5. So I went the wrong way, x minus 6, x plus 5. So my least common denominator is x minus 6 and x plus 5. So now what you want to look at is you want to look at each fraction and see how do you need to adjust it. In other words, what is it missing in the denominator? This first fraction isn't missing anything. It already has the common denominator, so I'm not going to do anything with it. The second fraction is missing an x minus 6, so whatever I need to put on the bottom, I also need to put on the top. So I like to kind of write that out to show what you are multiplying top and bottom by to get it to have that common denominator. So I already have established my denominator is going to be x minus 6, x plus 5. Now I have to look at what's going to be in the numerator. In the first fraction, we just have an x. Nothing got multiplied by it. In the second fraction, we have a minus 1 times x times negative 6. You can either write it like this and then distribute, or you can do it all in one step. X minus x plus 6. I have like terms, an x and a negative x will cancel. So my final answer is 6 over x minus 6, x plus 5. For the next one, nothing to factor here. Right now, I have one denominator that's an x, one denominator that's an x squared. That is the same factor, just repeated. So I need to use the highest power that we see, which is the squared, as part of the least common denominator. And I also have to have the x plus 3, because that is a unique factor. So I'm going to look at every fraction and see what it's missing. The first fraction, the denominator is missing an x, and it's missing an x plus 3. So I need to multiply it here, and I need to multiply it here. The second fraction is missing the x plus 3 in the denominator, so I need to multiply it Sorry, my pen's going a little crazy on me. I need to multiply it here, and I need to multiply it here. The last fraction is missing an x squared, so I need to multiply it here, and I need to multiply it here. So we know that our denominator is x squared, x plus 3. I like to write that right away, or else sometimes we forget that there was a denominator there at all, because we focus so much on the numerators. And then I want to write down what happens up here. So I have a 4x, x plus 3 for the first fraction. I have a minus 2, don't forget that minus sign, x plus 3 in the second fraction. And I have a plus 4x squared in the third fraction. Now it comes into a lot of distributing, combining like terms. Basically from here on out, it's doing a lot of multiplying out. So when I multiply it out, I get 4x squared plus 12x minus 2x minus 6 plus 4x squared. I'm not going to write the denominator down yet because I kind of want to clean up the numerator a little bit. So I have 4x squared, and 4x squared is 8x squared. I have 12x minus 2x is 10x minus 6. I can take a 2 out of that. 4x squared plus 5x minus 3. The only reason I'm doing that is I'm trying to figure out if this will factor further. Because if it does, there's the potential that we could cancel like we did in the previous section. So let's do a quick check to see if this will factor. We need to get 4, so it's 2 times 2 or 4 times 1. This is 3 times 1 for sure. This is a positive and a negative. 2 didn't show up very well. Let's see. We could do 4 times 1. We could do 2 times 2. See if there's any possible way to get a 5x in the middle, kind of going through the options. 3, 2, I don't see any way that that is going to factor. Want to make sure I'm not missing any. No, I don't see any possible way to factor that. You could also run through a basic quadratic formula to check to see if you're getting any rational answers. Since it doesn't, my final answer then will just be this numerator, 2 times 4x squared plus 5x minus 3 over my common denominator that I had all along, which was x squared, x plus 3. And that is my simplified answer. It's as far as I can go with that. Continuing with the idea that we are trying, again, to factor and get this common denominator. So this factor is x plus 3, x minus 3. This one is actually already factored for you, the second fraction. So my LCD has got to be x plus 3. It's got to be x minus 3. And I also need an x. I have this factor, I have this factor, and I have this factor that are all unique factors. So looking at the first fraction, I am missing the x, so that means I need to multiply the top and bottom by x. Looking at the second fraction, I am missing an x plus 3, so I need to multiply the top and the bottom by x plus 3. So my common denominator is x, x plus 3, x minus 3 in any order. My numerator, when I take x times x, I'm going to get x squared. And then I'm going to have plus 3 times x plus 3. If you can distribute that in your head, that's fine. X squared plus 3x plus 9. You can check to see if x squared plus 3x plus 9 would factor. It doesn't. There's only a couple ways to get 9, and none of them will give you the right middle term. So this is a simplified final answer. And then the last one. This is x plus 2, x plus 2. And it is a little easier to help us in this process to write it as x plus 2 squared. That will help us identify the least common denominator. This is x plus 2, x minus 2. And that last one doesn't need to be factored. So my least common denominator on this one is going to be this x plus 2, and it needs to be there to the second power. That takes care of this x plus 2 that's already there. The only other unique factor is x minus 2. So looking at the first fraction, it is missing an x minus 2, so I need to multiply top and bottom. Looking at the second fraction, it is missing an x plus 2. So I'm going to multiply top and bottom. And looking at the last fraction, this is missing an x plus 2 squared. Or you could write out x plus 2 if that's easier. So my common denominator is x plus 2 squared, x minus 2. My first fraction I'm going to have to FOIL, so you can either do it in your head or you can write it out and then do it. I'm going to just write it out and then we'll go through. My second one, don't forget there's a minus sign, so we have minus 6x times x plus 2. And the third one, I'm going to have 3 times, I am going to square it out just because it'll save me a little space here in a second, x squared plus 4x plus 4. Now when I do my foiling and my distributing, I can see what combines. So when I FOIL the first two, I get 2x squared. My outer is x, my inner is negative 4x, so I get negative 3x minus 2 minus 6x squared minus 12x plus 3x squared plus 12x plus 12. I still have that denominator, but I'm going to hold off writing it for a second because I want to combine and simplify this a little bit. So all my x squareds, 2 minus 6 plus 3 gives me negative 1x squared, or just negative x squared. Negative 3x, negative 12x, and 12x, and negative 12x, and 12x will cancel. So I just have the minus 3x. And then my minus 2 and plus 12 give me plus 10. I'm going to factor a negative out. I don't like a negative leading coefficient, so I get x squared plus 3x minus 10. That actually will factor even further. Now I'm starting to run out of a little bit of room here. I'm going to go to the next slide so you can see it. So I took out a negative, and I'm left with x squared plus 3x minus 10. And I'm looking at what I had, x squared plus 3x minus 10, and it's over my common denominator of x plus 2 squared, x minus 2. I'm going to see if I can factor that top a little bit. This one I think is going to work out a little nicer. That factors x plus 5, x minus 2. And the reason that it was important to do that is because we actually have a little bit of simplifying. Looking at kind of the section before this, the x minus 2 factors will cancel. My final answer is negative and then x plus 5. If you want to distribute the negative in, you can. If not, you can leave it as is over the denominator of the quantity x plus 2 squared. So that takes you through the first half of 9.5. I didn't get anything into complex fractions here. That's going to be a separate video. But it takes you through the process of how do we identify the least common denominator, how do we adjust all our fractions to have the least common denominator, and then how do we simplify to get our final answer when we're done with our adding and subtracting.